Welcome to another tech video from your very own The Tech Cult powered by DeltaEdge Networks. Today we're diving deep into BGP, advanced troubleshooting and policy design for 2025. The kind of interview content you'll face if you're a mid-level network engineer or preparing for certifications like CCNP or CCIE. We'll cover path selection, policy design, real troubleshooting cases, and finish with a downloadable cheat sheet. So make sure you stick around till the end. What interviewers expect. In a BGP interview, it's not just about memorizing commands. Interviewers want to see if you can reason through why routes behave the way they do and how to control or fix that behavior in a real network. They look for a solid understanding of BGP path selection logic, the ability to design scalable policies using attributes or communities, practical troubleshooting skills, and vendor awareness across Cisco, Juniper, and Arista platforms. Path selection logic. The most common BGP question is, how does BGP pick the best path? Here's the correct order. And make sure to say it clearly in interviews. Highest weight, highest local preference, locally originated routes, shortest AS path, lowest origin type, lowest MAD, only if from the same AS, eBGP over iBGP, lowest IGP metric to next hop, oldest path, lowest router ID. And remember, always mention same AS in the med rule. It shows mastery. Convergence problems slow or failed. BGP convergence is a common challenge. If a router doesn't receive updates properly, start your checks like this. First, verify next hop reachability. Many missing routes are just IGP problems. Then check your route reflectors. They might not be updating non-client peers. Watch out for mismatched BGP timers or authentication keys, which often cause flaps. If everything looks fine, run a debug BGP updates carefully. It often exposes hidden policy rejections. Community-based policies. BGP communities make policy design scalable and elegant. They let you tag traffic classes instead of building endless prefix lists. For example, use 65,100 for premium routes, and 65,200 for standard routes. Then use a route map to match those communities and apply outbound policy logic. Also, never forget the well-known communities. No export, no advertise, and local AS. Interviewers love seeing you use them. Route reflectors and loops. Route reflectors reduce iBGP complexity but can create suboptimal routing or loops. Interviewers often ask, what prevents loops in an RR design? The answer? Cluster ID and originator ID. If routes don't reach clients, check those values. Duplicate cluster IDs or mismatched originator IDs can suppress updates. And always remember, the best path seen by the RR might not be best for the client router. eBGP versus iBGP. Another favorite interview question. What's the difference between eBGP and iBGP? eBGP peers use TTL of 1 by default, meaning direct connection is required. iBGP uses TTL 255 and typically needs full mesh or route reflectors. And the famous question, why do we use next hop self? Because iBGP doesn't change the next hop attribute when advertising routes. So without next hop self, your routers may not reach that next hop. Policy design example. Let's apply policy logic to a real scenario. Your enterprise connects to 3 ISPs, A, B, and C. You need ISP A for voice, ISP B for backup, and ISP C for bulk traffic. The design approach: set higher local preference for ISP A, use as path prepending or communities to make ISP C less preferred inbound, and apply conditional route maps for prefix level control. This demonstrates true network design thinking. Best practice Quickfire. A few quick but powerful tips. Avoid BGP dampening unless absolutely needed. It delays convergence. Use aggregation where possible. Enable graceful restart to prevent transient route loss. And use community tracking to prevent policy loops. These are short answers, but they impress every interviewer. Verification and troubleshooting. When verifying BGP, always start with the basics. Show IP BGP summary. Checks neighbor states. Show IP BGP. inspects attributes. Show IP BGP neighbors, shows policies. And when you suspect filters or attribute mismatches, use show route map or debug BGP updates. These commands demonstrate real troubleshooting confidence. Real interview scenario. Now, imagine this. Two routers, R1 and R2. R1 sees a route, but R2 doesn't. How do you start? Step 1. Check if the BGP session is established. Step 2. Review inbound and outbound filters. Step 3. Validate next hop reachability. Step 4. Inspect route maps and policies. If all looks fine, debug the updates. You may find attribute or community mismatches. And that's a wrap on BGP Advanced Troubleshooting and Policy Design for 2025. You now know the attribute order, the policy logic, and the key troubleshooting flow. Remember, BGP isn't just configuration, it's control plane engineering. If this video helped you prepare for your next interview, download the BGP cheat sheet linked below. It includes attribute orders, policy examples, and sample route maps. Comment your toughest BGP question. We might feature it next time. And don't forget to subscribe for our next video. MPLS Traffic Engineering and Fast Reroute Interview Scenarios for 2025. Thanks for watching and see you in the next one.